Welcome back to another math video, ladies and gentlemen. Today we are going to be talking about, we're still going to be talking about solving triangles, so finding everything that can be found in a triangle. But today we're going to be talking about story problems, okay? So we'll have a story problem that will sort of set up our triangle that we'll be able to use to draw, and then from there we will then find our triangle, find all the stuff about our triangle, okay? So here's the problem you're going to start with today. Might only have one problem. We'll see. We'll see how long this takes, and might do two. We'll see. So if we have a 15-foot long ladder, the ladder is leaning against the wall. So we're going to say that the wall, that this is our wall, right here, and then this is our ladder. All right, our ladder is 15 feet long. 15 feet long, and our ladder is making a 23-degree angle with the ground. So we're going to say the ground is down here, and our angle down right here is 23 degrees. All right, so we have a 15-foot long ladder. It's making a 23-degree angle with the ground, and it is leaning up against a wall. Okay, so we have three questions that we're going to try to answer. Question one, which is how far is the base of the ladder from the wall? So that is our base of the ladder from the wall. We're trying to find this space here. Question two, what angle does the ladder form with the wall? So what angle does our ladder form with the wall? And then question three, which is how high up the wall does the ladder reach? So we're trying to figure out how tall this ladder, or how high this ladder is from the wall. Okay, so we have three questions we're trying to solve. We have some information that we are trying to figure out here, so let's get cracking. So first, let's see if we can figure out how far the base of the ladder is from the base of the wall. Well, we're going to call this ladder, this space right here, we're going to call x. So if we are looking at our 23-degree angle, we are going to take x, which is our adjacent side, and 15 feet, which is our hypotenuse. Hypotenuse and adjacent, using our SOHCAHTOA stuff, is cosine. So we're going to take cosine of our 23-degree angle. That's going to equal whatever x is divided by our hypotenuse, which is 15. To move that 15 over, we're going to go ahead and multiply both sides by 15. And that's going to leave us with x equals 15 times cosine of 23 degrees. And then, grabbing our handy-dandy Desmos calculator, we can find that, there it is. We can find that by typing that in, once we change our Desmos calculator into degree mode, because that's what we're dealing with here, we can find that if we take 15 times cosine, which is in our functions menu under trig, 15 times cosine of 23 degrees is going to be 13.8-ish. 13.8-ish. X is going to be 13.8 feet from the wall. 13.8 feet. All right. So then, which hopefully makes sense, 23 degrees is not a very large angle, so this triangle is not really drawn to scale at all. So if 23 degrees, it's kind of laying really flat. So that would hopefully tell you that if I made this angle a little bit better of a picture, that it would be reaching out farther from the base of the wall than it should be going up the wall. So our answer for how far is it from the base? How far is the base of the ladder from the base of the wall? Is going to be 13.8 feet. So then, if we want to find this angle here, what angle does the ladder form with the wall? We can do our wow, it literally just jumped out of my brain. We can do our triangle sum theorem, where all the angles in a triangle have to add up to 180. So if we take our angle up that we're looking for, we'll call that angle theta. We'll call this theta here. Theta plus the 23-degree angle plus the 90-degree angle should add up to 180. So theta is going to be equal to 180 minus 90 minus 23. And that is going to be, theta should be 67 degrees. So this angle right here should be 67 degrees. And our angle that the ladder forms with the wall is 67 degrees. Okay. So triangle sum theorem let us find that. So now let's find how high up the wall the ladder reaches. So we know two of our sides, so we can, since we know two of the sides of our right triangle, we can use our Pythagorean theorem. So we can take 13.8 squared plus the wall squared should equal our hypotenuse, which is our ladder. Ladder squared, which we know how long our ladder is, which is 15. Our ladder is 15 units long, so 15 squared. So wall squared should be the same thing as 15 squared. I'm just going to subtract this 13.8 from both sides, minus 13.8 squared minus 13.8 squared. So we have 15 squared minus 13.8 squared, whatever that number ends up being. So let's go ahead and ask Desmos, what is that number? So we're going to say 15, get cleared, go away. So here we have 15 squared minus 13.8 squared. So that's going to leave us with 34.56. So our wall squared is going to be 34.56. Now to get rid of the square, we square root 34.56. Did it again. 34.56. And we want to find the square root of that. So I'm going to put this back up here and square root. Of course, why would it go underneath? That would just be useful. Square root of 34.56. So we get that our wall height is going to be about 5.9. Wall is going to be equal to about 5.9 feet. So this is going to be 5.9 feet. And our ladder reaches 5.9 feet up our wall. Okay? So essentially we wanted to find all the other things about this scenario that we didn't know. Same idea as yesterday. Now we're just putting stories behind it. Okay? All right. We will have a conversation tonight with Mrs. Studebaker, and I will have another video for you guys tomorrow. Okay, bye.